we will understand importance of mean value theorems in calculus. Mean value theorems in calculus are very important. They are called central points of calculus because using mean value theorems we can prove fundamental theorems of calculus, and fundamental theorems of calculus gives relation between derivative and integration. Here we will geometrically verify Lagrange's mean value theorem. What is geometrical interpretation of Lagrange's mean value theorem? If we draw a secant line for a continuous and differentiable function joining any two points, then we can always find an intermediate point where the tangent drawn at the intermediate point will be parallel to the secant line. We will verify Lagrange's mean value theorem for fx is equal to x square. Here we have drawn secant line between point x is equal to 0 and x is equal to 2. Now we want to obtain a point between x is equal to 0 and x is equal to 2 such that the point will lie between 0 and 2 and the tangent drawn at the intermediate point will be parallel to this secant line. As you can see, I am trying to obtain a point between 0 and 2 such that tangent drawn is parallel to this secant line. You can observe that these two lines are now parallel. This is secant line which joins 2 points on the curve. X is equal to 0, so the point is 0, 0. X is equal to 2, so the point is 2, 4. This is secant line, and we have obtained a point C. Approximately the value of C is 0.87, as we can see it graphically, so that tangent drawn at point C, which is intermediate to point A and B, is parallel to this secant line. Let us verify this function, this Lagrange's mean value theorem for another function sin x. I want to obtain a point C between 0 and 2, that is point between points A and B, in a way that tangent drawn at point C will be parallel to this secant line. We can observe here that these two lines are parallel. This is secant line which joins 2 points on the sine curve, x is equal to 0 and x is equal to 2. So this is secant line joining 2 points on the curve, and this is a point which is intermediate to 0 and 2, and the tangent drawn at this point is parallel to this secant line. Finally, let us verify Lagrange's mean value theorem for the function fx is equal to x cubed. We are taking points A is equal to 0 and point B is equal to 2. We want to obtain a point between A and B in a way that tangent drawn at this point will be parallel to this secant line. Again, graphically we have obtained this point where tangent is parallel to this secant line. In this way, we can verify Lagrange's mean value theorem for any continuous and differentiable function given the interval. Thank you.